Dr. John Vervaeke. Many of you in the room have heard of or attended John's lectures. John's been teaching here since '94, which dates me because I took Intro to Cognitive Science with John in '95. Dr. Vervaeke has won numerous teaching awards, both bottom-up, as in student-driven, and top-down, as in faculty and administration-driven. He teaches in the Buddhism, Psychology, and Mental Health program, he teaches in the Psychology program, and he teaches for the Cognitive Science program. A really active instructor, researcher, and colleague. John, come on up and save me.
Thank you very much. That was some very excellent introductory remarks, and they actually key into some things I want to address. This idea about the sense of importance and connection, and issues about the kind of meaning crisis we may be facing today. But my talk is actually, might not initially seem like I'm going to be addressing that, because I'm talking about a cognitive science of wisdom. And why a cognitive science of wisdom? Well, one of the things I want to argue is that wisdom is actually a quintessential cognitive science topic. Now, what is cognitive science? Cognitive science is an attempt to create a synoptic integration between many levels of discourse that talk about the mind, very broadly construed. So, neuroscience talking about the brain, and then you have machine learning talking about types of information processing. When the brain is processing information, is it processing it as a computer, as a neural network, as a dynamical system? And then a level above that, we study the mind by studying behavior. When people are solving problems, when they are behaving rationally, we try and understand the nature of their mind by looking at their behavior, and this is, of course, is psychology. And then we also have to study how minds link together, how they communicate and share with each other. And this is, of course, where we talk about disciplines like linguistics and sociology and anthropology. And then, of course, and you may wonder, what did the philosophers do? And that's a question we often always wonder. But they do something very important. This is a place where philosophers have a really important job, because philosophy has been the long-standing attempt to provide a synoptic integration, to take important concepts and theoretical material and data from these various disciplines and ask, how does it all fit together? What does it all mean for us? And it makes uses of tools of plausibility reasoning and conceptual innovation and insightful integration. Now, the thing is, when you turn to study wisdom, you find exactly the same thing going on. You find that all of these levels of discourse are already significantly contributing to it. So you have Meeks and Jest, neuroscientists talking about wisdom. You have a host of people in psychology talking about wisdom. Famously Baltzan-Staudinger, Sternberg, people like that. Michel Ferrari. I don't know if Michel's here right now. He'll be here tomorrow. Right? We definitely have people talking about this at a higher level. Monica Ardelt is here. She's from sociology, and she's going to be talking about a linguistic phenomena associated with wisdom, namely paradox. So you see all of these levels are being addressed. And therefore, cognitive science is very well set up to actually tackle this very important topic. Now, it's an important topic because, as has been mentioned before, not only is it perennial in the sense that for a very long time, the topic of wisdom has been connected to the perennial human project of what makes life good, how do we avoid being foolish, how can we be better people. And so there's those perennial concerns. But of course, wisdom has now become a crucial concern because, as I mentioned, we seem to be facing a series or maybe a set of interconnected crises. And the hope is that perhaps wisdom could address that. So what do we mean by wisdom? Well, that's part of what I want to try and talk about. And I want to try and give you a cognitive science account of it. Now, as I go on, I want to, first of all, give credit where credit is due. A lot of this argument has been done in conjunction with one of my colleagues and co-authors, Leo Ferraro, who you've already met. A lot of significant work has also been done with Greg Kasoris, who is the president of the CASA Society, and some other work was done with Zach Irving, who I don't think is in attendance today. So So what I want to say is that wisdom involves some kind of comprehensive enhancement of our cognition, some kind of improvement of it. And by cognition, I mean very broadly construed, that broad, multi-level construal to cognition. Some kind of, comprehensive enhancement of our cognition that would improve our life, make our life in some sense better, and perhaps afford us the abilities to address these pressing concerns in our society today. Well, what we need then, if we're going to talk about a comprehensive enhancement of cognition, we're going to need to try and zero in on some central process of cognition, some pervasive aspect of cognition that is constitutive of it, that is nevertheless found on all of these levels and makes an important impact on all of these levels. Now, in 2009, myself and Tim Lillicrap and Blake Richards, we argued that such a central cognitive phenomena has emerged in cognitive science, and we even argued that cognitive science is now in its second generation tending to reorient itself around addressing this central phenomena. Now, it may surprise some of you to know that I think of that this phenomena is the phenomena of relevance realization. And that was, in fact, the main point of the argument in 2009. I'm going to review some of that very, very quickly with you. Why would you think that relevance realization is a central aspect of cognition? So, if we take a look at organisms trying to survive in the world, we can understand that as something like problem solving. Organisms face certain obstacles as they try to achieve goals, and they have to do things to modify those conditions, those obstacles, so they can reach their goals. This is problem solving. Now, one of the most interesting things that's happened, and it was one of the things that actually started the foundation of cognitive science, was that this idea of problem solving was actually formalized by the seminal work of Newell and Simon. And they formalized problems as basically something like this. I start with an initial state, and I'm trying to get to some goal state, right? So, I'm hungry, and I don't want to be hungry anymore. The standard one, right? And the idea is there's several things I could do. I could do this, and that will transform me to that state, or this to that state. And then once I get here, there's maybe 2 things I could do. Maybe there's only 1 here. But then once I get here, there's 3 more, and so on. And the idea is eventually what you get is a series of transformations that will turn your initial state into your goal state. And that looks all like, yeah, so what? We didn't need, scientists to tell us that. What was important is what was revealed by this. A very important fact was revealed. Because don't be misled by the diagram. You see, you're taking a God's eye point of view about this. You can look down from above and see which is the pathway. But when you're actually a problem solver, you're here, and you don't know which one of these pathways is going to get you to the goal state. So you're having to choose, you're having to select from all of these pathways. And you say, yes, and? Well, the issue is the amount of choice available to you. The way you calculate the number of the pathways is given by this formula, F to the D, where F is the number of operators you can perform at any time, and the D is the number of sort of steps you can go through. So let's take a standard sort of thing. This is a standard example. You're playing a game of chess. At any turn, you have 30 moves you can make, and average game lasts about 60. So that's the number of alternative pathways for playing a game of chess. Now that's a big number. That's more than the number of electrons in the universe. So how do you solve this? I mean, things your grandfather told you can't be right. Your grandfather told you, oh, trial and error, hard work, right? Just keep going at it. The problem with that, that's no good. I mean, here's your chance that any one trial is right. And even if you do 1,000,000 of those, you're pathetic, okay? That's not gonna work. This is known as combinatorial explosion. Now, what it turns out, and this is why you know that's good science, because the conclusion seems paradoxical or counterintuitive. That's how you can tell when you're starting to do good science. It looks like what makes us intelligent is our ability to ignore information. That sounds kind of like a Zen koan. What makes you wise is your ability to ignore, or something like that, right? But here's the idea. Of all of the information available, somehow, this is what we do. We only search a very small, that's even probably too large, subsection of this information, we somehow zero in on the relevant information and ignore or deem the rest of this information irrelevant, and we don't even explore it. Now, we're not perfect at this, and this is part of the point I want to make. We can't be perfect. The only way to be perfect would be to search all of these, and no finite rational agent can do that. But what is amazing is how good we are at this. We can somehow very often zero in on the relevant information. But relevance matters even more than that, because many of the problems, this problem here, for example, the way I've laid it out, I know what the initial state is. I know what the goal state is. I know what all the operations are I should perform. That's called a well-defined problem. The problem facing me as I try to give this talk is I'm not in a well-defined problem. Giving a good talk is a very ill-defined problem. I don't even know what the initial state is. We saw the initial state was unexpected, right? I don't know what the goal state is. What does a good talk look like? What are the invariant features? What do all good talks possess? Other than, tautological things like they're good, and other people say, well done, John, and things like that, right? What operations should I perform? Well, I should talk, yeah. What should I talk about, and how should I talk? Should I move around a lot? Should I use a lot of gesture, right? My wife makes fun of me because I tend to use too much gesture, right? So we don't know what the operations are. Now, what that means for these ill-defined problems is your main task is actually formulating them as problems, turning them into a form that you can actually then move through. Now, it turns out that problem formulation not only helps you with your ill-defined problem, but problem formulation is exactly what you're doing when you're doing this. When you're formulating a problem, you're putting boundaries and conditions on it so that you avoid all of this combinatorial explosion. But it gets even worse, or maybe better, depending on your point of view, because relevance plays another important role. Because if we're going to be actual, real, embodied actors in the world, right, we have to be capable of some very central abilities. We have to be capable of determining the consequences of our own behavior. That's what distinguishes an agent from something that is merely happening. Agents, in some sense, are directing their behavior, so if this table falls over, it's not an agent, because it's not directing its behavior. It's not looking at the consequences of its own behavior. Now, the thing is, to have something pay attention to the consequences of its own behavior turns out to be extraordinarily difficult. So many of you have seen this before, and this is from Daniel Dennett. Let me give you an example of this, a thought experiment. So I'm going to make a robot, right? And I'm going to make the robot, it's going to have a very simple job to do. It's going to just go and retrieve batteries and then take them to some location to consume the energy. And that's not bizarre. Most organisms do that. You do that too. You do not consume your batteries upon first seeing them. You don't walk into the grocery store and go, food, right? You take it somewhere, social bonding, primate horde, we will all hunt together, all that sort of stuff, right? So you do that, right? Let's put that the robot's looking for a battery, and what the robot can deduce is that one of the consequences of its action of, for example, pulling the wagon is that the battery will come along too. And that's great, because it wants to take the battery. Now what I'll do is I'll make this a more difficult situation for the robot. There's also a lit bomb on there. And so what happens is the robot pulls the wagon, and as intended, the battery comes along, but so does the bomb. The bomb blows up and kills the robot. So we, as good cognitive scientists, say, oh, of course, how stupid of us. We have to make the robot not only pay attention to the intended consequences of its action, we have to make the robot pay attention to the unintended consequences, what we call side effects. You're familiar with this with the problem in medicine. Take this, put this poison in your body. Here's the intended effect. You will no longer have this parasite. Here's all the, you watch commercials now on TV where they're trying to get medicine, the side effects are overwhelming. They may cause blindness, may cause you to vote for a Republican president, stuff like this. It's a long list, right? Okay, so, right? We have to make this look for the side effects. So we make our robot, and now it's going to look for the side effects of its action. And we put it into this situation, and we find it there computing and computing and computing, and then nothing happens. The bomb blows up. Because it's computing, it's trying to compute all the potential side effects. That if it pulls the wagon, the left wheel will move more than 1 millimeter. The right wheel will move more than 1 millimeter. The overall pattern of reflections is going to be changed. There's going to be indentation in the grass. Some of the air is going to be deflected in a different way. The position of the wagon with respect to Jupiter has been altered. And then we go, oh, we're stupid. We can't get it to pay attention to all of the side effects. That approaches infinity. So what we got to have it do is we have to and here it comes, we have to get it to somehow zero in on just the relevant side effects. And this is what it can't do. It can't list all possible effects and then pick out the ones that are relevant, because that's still going to overwhelm it. It has to somehow, again, ignore overwhelmingly most of the side effects. It has to zero in on what's important to it. We heard this invoked already in the opening talks. There's similar ideas, I can't go into it, in linguistics, right? You know, linguistics depends on something like an ability to categorize things, nouns and verbs, actions, objects. Categorization requires relevance realization. I mean, here's the standard model we were taught from Sesame Street of how we categorize. Well, we notice that two things are similar, and we group them together, and we notice that two things are dissimilar, and we keep them apart, and there we go. And that is a fundamental mistake. I mean, it's good for Sesame Street, right? It's a fundamental mistake because we're making a deep confusion. We're thinking that similarity is an intrinsic property of things, that things are just intrinsically similar, like the way they intrinsically have mass. But they don't. And this is Goodman's point, famously, any two objects are infinitely similar or dissimilar because there's an infinite number of truths that apply equally to them. You know, so I take, you know, a plum and a buffalo. Well, you know, they're both organically based. Neither one was around 300 million years ago. Both have an odor. Both can be found in North America. Neither one makes a particularly good weapon. Neither one is a particularly good pet. Those are all true. Now what you should say is, well, those are kooky, and what you're meaning is, those are what? Irrelevant similarities. Those don't matter to me. I don't care about them. And that's exactly right. What matters is in categorization are relevant similarities. Okay, so relevance realization is like crucial, central. You're just not a cognitive agent if you're not doing relevance realization. Now, it should strike you as paradoxical, because in a sense, like as I said, this is a very weird phenomenon. Like, what does it mean to intelligently ignore? Well, part of what I mean by that is this framing that we're doing, the way we're confronting information, right? And we're basically putting a frame around it, right? And we're ignoring what's outside that cognitive frame and concentrating on what's going on inside of it. So what's outside is relevant, what's inside is relevant. But we have to do this intelligently, and that has two aspects to it. We have to somehow zero in on the relevant information, but another thing I mean by intelligently is we have to do this flexibly, because often we misframe things. So you knew I was going to do it. I'm going to talk about the 9-dot problem. Okay? So here's the very famous problem, right? Here's 9 dots. I have to join them with 4 straight lines. I have to start the next line from the terminus of the previous line, and this is one of the most studied phenomena in psychology. It's getting up there close to the Stroop effect. Okay, and people think initially, what's the problem? 1, 2, 3, 4. Oh, I missed the center. 1, 2. 1, 2. Oh, and by the way, we measure how much they pause and make noises like that. Pausing is actually predictive of how well pausing and moaning is weakly predictive of whether or not you'll actually solve the problem, by the way. It doesn't work causally, though. It doesn't mean you can improve your problem-solving performance by moaning a lot. Okay. Okay, so you give one solution to people, right? Here's one, right? Sorry, my lines aren't straight because my dots aren't exactly laid out properly. And people get upset, and they say, you cheated. And they actually say things like that. And they say things like, you went outside the box or you went outside the square. And then you point out to them, at no time did I ever say square. At no time did I say box to you. And what happened is, you saw this and you projected a pattern. And then you understood the problem. You formulated the problem as, oh, right, make a closed figure. I know how connect the dots work. What's inside the square, because I heard 4 straight lines, is relevant. What is outside is irrelevant. And by framing the problem in that way, you boxed yourself in. No pun intended. Now, a couple of points about this. Telling people to go outside the box doesn't help them much. It was mentioned the distinction between sort of propositional and procedural processing. Telling people go outside the box doesn't help them. Interestingly enough, which is kind of funny, because they think outside the box and think outside the box, all that's irrelevant, because actually uttering those words to people doesn't motivate them to do it, doesn't enable them to do it. It's very strange. But advertisers don't care about the truth, so what does it matter? One of the things I can do that helps, let's say I have the 9-dot problem. So let's pretend this is the page, and then I draw a big box like this around it. Right? That will help people solve the problem. Now think about it. That's because this is actually working at a procedural level. I'm not telling you facts. I'm getting you to redirect your attention and alter how you're distributing salience. And that's what you need to do in order to solve this problem. You need to be able to alter, right, your attention and what you find salient. So this is called insight. Right? This is insightful problem solving. Now, insight is very, very relevant to wisdom. I mean, it doesn't strike us as odd as we say, well, Sam isn't very knowledgeable, but he's very wise. People go, yeah, okay, I can get that, right? And people say, well, Agnes is very creative, but she's very foolish. And we go, yeah, I can see that. And then somebody says to us, you know what, Peter's not very insightful, but he's very wise. And that strikes us as, what? That's odd. That doesn't seem right. And that's not just a folk intuition. A lot of researchers who have done reviews of this have pointed to the fact that insight is playing a very central role. So like I said, Meeks and Just, who I mentioned earlier, Bluke and Gluck have talked about it, McGee and Barber, that insight is central. But we have to be a little bit careful here. Insight is kind of the phenomenological tip of the iceberg. That aha moment that we're aware of is only an explicit example of this much more pervasive phenomena of flexible relevance realization that is going on at all levels of the brain. For example, when you categorize this as a table, you probably didn't experience that as an insight experience, but nevertheless, it was making use of that flexible relevance realization. Okay, so that's cool and everything. So let's just explain relevance realization. Because if it's so central to cognition and we understand what it is, then what we can do is improve it, and we'll become more insightful, we'll become, perhaps more intelligent. Wow, isn't that wisdom? And you'd be sort of right, but then you're going to hit a really hard problem. You can't come up with a theory of relevance. And you're probably thinking, well, this is what I have to do. I mean, I have to figure out what relevance is, how we detect it, and then how we respond. But you can't have a scientific theory of relevance for some very good reasons. Science requires, categories that have stable, homogeneous intrinsic properties, because that's the only way you can make the inductive generalizations that science uses. And that's why you can't have a science of things that happen on Tuesdays. It's not because there aren't things that happen on Tuesdays, but the class of things that happen on Tuesdays isn't stable, isn't homogeneous, and it's pretty clear that Tuesday probably isn't intrinsic to the physics. You can't sort of, we discovered the Tuesday particle yesterday or something like that, okay? And he may say, oh my God, we got all this way and now this is bleak and despairing. You're supposed to be helping, right? Well, it's not really that much of a problem as long as you stop trying to come up with a theory of relevance. And I want to give you a very powerful analogy. So consider Darwinian fitness. Now, Darwinian fitness is almost tautological in it's basically whatever enables evolution to keep going, because it's whatever enables organisms to successfully pass on their variation and their ability to compete with each other, right? And the thing is, the class of things that are fit is not stable or homogeneous. I mean, I'm obviously, in some sense, fit, and so is a paramecium, but we're fit in really different ways. I don't think I have much in common with parameciums. I hope not, right? And the things that make me fit right now might make me disastrously maladaptive if the environment changes in a certain way, okay? Now, when people were trying, before Darwin, to figure out design, they were looking for, the intrinsic features of perfection, of perfect design. And so people were, trying to see God's plan in things. They were looking for the intrinsic features. And one of the great insights of Darwin was to break away from that and to frame things differently and say, no, I'm not going to come up with an account of fitness. I'm going to come up with a process by which fitness is being continually, contextually realized. And then from that realized context, a new form of fitness can evolve. And then from that, a new form of fitness, and so on and so on. And what I'm going to propose to you is that although we can't have a theory of relevance, we can, of course, have a theory of relevance realization. We can come up with an account. Now, that has some important implications for our account of wisdom, because if wisdom is dependent on relevance realization, certain types of theories that we might want, like, definitive invariant, product model, this is what wisdom just is all the time, might not be appropriate. We're probably going to have more of a process model in which we describe the maybe universal processes by which by which wisdom is continually being recreated in a contextually and historically sensitive manner. Now, what might that look like? Well, if I was to try and explain what I think how relevance realization works, that's another whole talk. And it's a longer talk. It's a 7-hour talk. And we don't have 7 hours. I just want to give a bit of an idea about what it involves. So consider a famous problem, okay? Here's one. So you read that, and what do you say it is? What does it say? What does it say? The cat. Thank you. Now notice what's going on here. These two things, and I can actually rig this so these are actually identical. But you read this as an H and this is a A. Now, in the old sort of computational paradigm, this is problematic. Because you end up saying, you get into this ridiculous thing where you say things like, oh, in order to figure out the features, I have to know what the whole thing is, the whole word. So in order to read the letters, I need to read the word. But of course, to read the word, I have to read the letters. Oh my God, reading must be impossible. And it's not. Because what you do is you have sort of two levels of processing. Well, I won't draw it all here, right? And what I have is I have opponent processing going back and forth between these levels. So for example, this will try and, enhance or reinforce the H being activated. This will try and enhance the being activated. It will inhibit this, and this will inhibit that, and so on. This was actually David Rumelhart's solution to this in neural networks, right? So what you've got is you've got a higher order level that's integrating, and a lower order level that's differentiated, and there's opponent processing going on. And it's opponent processing between this Gestalt level and the featural level, and it's also opponent processing between different alternatives. And what happens is the system self-organizes into a solution. Now, the important point to pay about this is how that happens across time, because as you're doing this, your brain sort of locks into one, integration, and then as you move over here, this process goes clickety-whir, that structure breaks up, and a new one has to emerge, because you then read the cat. You don't, right? And you don't read this as an H. So you have to, see, that's a little bit of insight. Did you feel it? Whoa. Right, okay. All right, now that's a very important process. Just think about what's going on here, right? What you have is a process of, you've got integration, and then a breakup of structure, followed by reintegration. And the integration often, will involve making use of previous, differentiation, which is what happened here. This is being differentiated from this. Okay? Now that's a very important process, because when a system is doing this self-organizing, integration and differentiation, the system is complexifying. For a system to complexify is for it to simultaneously differentiate its parts and integrate those parts together. So for example, in your personal development, you complexified biologically. You started out as a zygote. You were not very complex at all. And as you developed, you got a lot of cell differentiation. You got a lot of different kinds of cells. But you didn't become sort of a protoplasmic mass. Those cells became organized, that's into organs, that's where we get the word organized. So not only were you differentiating, you were integrating, and that made you a complex system. So you have, the thing about being a self-complexifying system is you get emergent functions. Complex systems can do things they couldn't do before. You can do things that you couldn't do as a zygote. Zygotes don't drive cars, they don't attend conferences. They don't do a lot of things that you can do. Now that's really important because if relevance realization is this process of self-complexification, that means not only is it a self-organizing, self-constituting process, it's a self-transcending process. And it's an interesting kind of self-transcendence because relevance, like similarity, isn't intrinsic. We have to project it onto the world, bind ourselves by it, but mostly to some degree, restructure it and then reproject, bind ourselves, reproject, like this. Now, that process of integration, breakup, reintegration, and complexification is actually being studied very seriously in physics. It's known as self-organized criticality. Self-organized criticality. And what's becoming really clear is that a prediction that Perkins made in 2002, very prescient, I'll come back to Perkins in a minute, that the brain was using this has been now really, really well confirmed. There's a lot of converging evidence that at many levels of analysis, and remember, relevance realization is happening at many levels of analysis, the brain is doing this, doing self-organizing criticality. What does that mean? You'll have a group of neurons and they will go synchronous. They're integrating their functions, they're integrating their processing. Then they will break up, neural avalanche. They will go asynchronous, and then they will reintegrate again. Self-organizing criticality. The brain is constantly doing that, spontaneously, as it's part of its very functionality. Now here's the interesting thing. There's now pretty good evidence, Thatcher and other people, that variations in this are strongly predictive of variations in general intelligence. That this process is the process that is making your brain intelligent. At least your general intelligence. Now that sounds, wow, that's great. You know, wow, we're sort of understanding, because look, I mean, that's what it means to be intelligent. That's what I've argued. To be intelligent, to be an intelligent agent is to be a good relevance realizer. This is probably how relevance realization is going on. That's why this is so predictive of differences in intelligence. But we have to remember that Perkins' article, where he predicted this, was actually an article about foolishness. What? Yes, it's called The Engine of Folly. Well, you're talking about intelligence. Doesn't being intelligent mean you're not foolish? No, and that's the point. It comes from a book, by the way, called Why Smart People Can Be So Stupid. Right? Because one of the main themes is that intelligence is not predictive of a lack of foolishness. Because Perkins' model was this, right? The very self-organization, this very dynamic, self-projecting, self-constraining, self-constituting process of relevance realizations, of self-organizing criticality that makes us so intelligent, also makes us vulnerable to ways in which the brain can self-organize and run away from us. I mean, that sounds weird. I'm not implying any dualism here. But self-organizing criticality can just, and because it's self-transcending, the process can just go off. I did this at the last Mind Matters conference, and I apologize for having to repeat myself, but I want to just quickly put this diagram up again. It's from the paper that Leo and I are doing. It's a chapter in Michel Ferrari's and Nick Westrait's forthcoming anthology on personal wisdom. Right, so you have some bad event happen to you, right? And what you're going to do is you're going to try and anticipate the likely probability of something like that happening to you again. Because when creatures are doing relevance realization, we have to remember that they're doing it in a very important manner. They're not just associating things together. This is what we've learned from learning theory. That whole sort of behaviorist model of what's going on in conditioning is wrong. Organisms aren't associating things together. They're trying to anticipate their world. They're trying to predictively prepare for their world. They're trying to predict the causal structure and prepare themselves for it. I mean, you don't have to take my word on that. Read the seminal articles by Rescorla, Hollis, Rumbaugh, right? That's what's going on. So if something bad happens to you, you're going to try and interpret and anticipate the likelihood of that happening again. The problem is you're going to run into a self-organizing process. You're going to try and tap your memory, and you're going to run into encoding specificity. Encoding specificity is that you don't just store, because you're storing things and how they're relevant to you, you don't just store the facts of a situation, you store how you were processing them, even at a physiological level. So if you're studying for a test and you have a headache and you take some aspirin, when you take the test, take the aspirin. It will actually improve your performance. Okay? So encoding specificity means that when I go into here, right, I've had some bad event, I get into a bad state. That will increase the probability that when I search my memory, I'm going to call up other bad memories. Oh yeah, other shit like this happened to me before, right? Now that is also going to interact with two other heuristics. Heuristics are ways your brain has of trying to ignore information. The problem with heuristics that help you ignore information is sometimes they turn into biases that make you ignore information. So we've got a couple that we use. We have the availability heuristic, right? And we have the representativeness heuristic, and they tend to reinforce each other, and I'll tell you why in a second, right? The availability heuristic is the ease with which I can remember an event is how I judge how probable it is. So encoding specificity means I easily remember these negative events. I then judge them as more probable. That means they're going to stand out in my mind more. That's the representative heuristic. We also judge how probable things are by how vivid they are. So now we're starting to think, oh, this is really, oh, yes, this is going to keep happening to me. Right? That's going to cause some anxiety. That's going to cause cognitive narrowing. When we're anxious and we're in this kind of state, we tend to focus in on detail, we tend to look more for error signal, we become much less cognitively flexible. Now the problem with cognitive narrowing is it actually reduces your ability to solve problems. So now you become poorer at problem solving. Now that's distressing. That feeds back into your anxiety because you're just screwing up. And it also feeds back to, right, another bias you have that all of these are also feeding into and feeding from, namely the confirmation bias. We tend to look for information that only confirms our hypotheses. And our hypothesis, things are really, really bad and they're going to get worse. And this confirms it. This, of course, also, right, causes anxiety. And I can keep going. This becomes a very complex self-organizing process that is running away from itself. This is why it's very hard to intervene in foolish behavior, because what happens is any one-shot intervention isn't going to work because the thing is going to self-organize and preserve itself. That's why these patterns of foolish behavior are so persistent and compelling. One-shot interventions or even stepwise intervention doesn't work. Now this is Perkins' point, this is the engine of folly. The very process that makes us adaptive is the very same process that makes us foolish. That's why it's so compelling, that's why it's so resistant to change. But we don't necessarily have to despair, because there is one way of dealing with such a dynamical system, and that's to cultivate a counteractive dynamical system. A dynamical system that can work in this dynamical, multi-level way. And I would argue that many of our wisdom traditions, in fact, argue for such a thing. I'll just mention one that I'm strongly affiliated with, namely the Buddhist tradition. So many of you are familiar with, the Eightfold Path. Right understanding, right vision, right speech, right action, right livelihood, all that sort of stuff. Now that right isn't primarily a moral right. So when they say right action or right speech, they mean what's most relevant, what's most appropriate. It's zeroing in on relevance realization. And not only what is most appropriate to this particular situation, but how is your right action, relevant to your right understanding. So it's all about this very dynamical process. And we know this because it's represented by an 8-spoked wheel. This isn't, right? You're supposed to be cultivating these all the time in a dynamically self-organizing process. And this is supposed to be, a self-rolling wheel. You're supposed to be cultivating a dynamical system that can actually counteract this profound runaway processing. Leo and I call this parasitic processing, because it's like a parasite. It takes up a life of its own within you and sucks life from you. But wisdom could be a counteractive dynamical system. Okay, well that's sounding a little bit better for us. But we then ask, well, okay, how then are we going to enhance relevance realization? How then are we going to make it better? And why is intelligence insufficient? If I'm not using my intelligence, what am I using? Well, there's a good answer to that, actually. And it has to do with the fact that when we talk about this relevance realization, when we talk about three different ways in which we're learning from when we're talking about relevance realization, we can talk about sort of three different ways in which we're learning from the environment. One of the things I can do is I can find relevant patterns in events. So I know how to interact with the world. I know what to do next. That's our procedural knowledge. That's knowing how to catch a ball. It's knowing how to find patterns and track patterns, dynamical patterns in events. But I don't want to know just about courses of events. I also care about conditions on those events. I care about facts. I need to know about cross-contextual conditions on many different courses of events. So no matter what action I'm going to undertake here, there's gravity. Okay? So I need to gain more abstract knowledge, abstract because it's cross-contextual, about facts, and facts aren't events. There can be facts about events, but facts aren't events. And this, of course, this is what our propositional processing does. This is our knowledge that Australia is a country and a continent. That's not an event. One day they decided and became a continent. I mean, it's right. It's a fact, right? And our propositional knowing, it is very different than our knowing how. In fact, it's very hard for you to translate between them. You know how to tie your shoelaces. Tell me how you do it. And have a small child and try to tell them how to do it. And you'll realize how you say useless, like grab the lace, and then they hold it like, no, not like that. Like sort of between your finger and your index finger, and then it's slipping. No, a little bit more, oh my gosh, how do I even do this myself? Right? So they can interfere with each other. In fact, one of the things I can do to really mess you up, like if you're typing and I say, tell me what you're doing to move your fingers to type, you'll go, right, and you just crash, right? So there's potential interference between these, lots of evidence for that. Now, in addition to your propositional learning, which is very inferential in nature, and your procedural learning, which is very much about patterns of interaction, you actually have another kind of learning. And this discussion owes a lot of work to work I do with Greg Katsouris, right? We integrate that together. We have to integrate knowledge and facts together. And we have to integrate it in a particular way. Remember, I'm trying to anticipate my world. I'm trying to not only formulate problems, I'm trying to find problems, and I'm trying to share them with other people, and so we can work together. I'm very much in this anticipatory relationship. Now, that means I have to predict the world, but I also have to prepare myself. It's no good predicting if I can't prepare. So I have to be doing this in an integrated fashion. I have to be modeling the world and modeling myself. Tracking the world and myself. See, I have to do this right now. And I have to be doing that so the way I integrate facts and courses of event together is relevant to me and affords me doing things that are appropriate to the situation. That's perspectival knowing. So propositional knowing is knowing that something is the case. Procedural knowing is knowing how to do something. Perspectival knowing is knowing what it's like to be something, to be in a situation, to take a particular position in the world. Now, what I'm going to suggest to you is that wisdom involves coordinating these different kinds of relevance realizations together, these different kinds of learning. But if I'm going to be coordinating learning, I have to be doing something other than just learning. Because in learning, I'm picking up on the world. But if I'm going to be coordinating learning, I have to be actually learning about learning. And this is known as the highly poetic name, learning to learn. In psychology, this is learning to learn. You're paying attention to your patterns of learning in order to improve how they can pay attention to the world. Now, why is this important? Because I want to suggest to you that when we try and ration, right? When we get into the logistics of our learning, when we try to best use our intelligence, when we try and step back and say, okay, this is how my intelligence works. So instead of solving a problem, I'm going to solve the problem of how to best use my intelligence. How do I ration out this resource? How can I best use it? Because I have to use it very carefully, because I can't process all the information. I'm getting into the logistics of this. I want to suggest to you that that's the essence of what rationality is. Rationality is to use learning to learn to try and manage the logistics of your intelligence. Now that would mean that the relationship between intelligence and rationality would only be weakly correlated. Because rationality is the recursive, right, feedback relation, right? It's intelligence fed back onto intelligence. So the relationship between intelligence and rationality is going to be very nonlinear. And that's in fact what Stanovich's work has shown, that the correlation between measures of general intelligence and measures of rationality is only about 0.3. And it has to be, because we've already seen from Perkins and others that intelligence does not inoculate you against foolishness. You need rationality. But we're going to need rationalities, because there's these three ways of knowing. We're going to need a rationality that protects our propositional processing, manages our inferential processing well, and protects it to some degree from being inappropriately interfered with by that procedural processing. Stanovich has studied this. He's made use of Jonathan Barron's idea of a cognitive style. Cognitive style is a set of learning to learn skills coordinated together. The cognitive style of active open-mindedness. Active open-mindedness is when you start to learn about how procedural processing can interfere with your propositional processing, and you actively, right, acquire skills for counteracting that. So we can have active open-mindedness monitoring our propositional processing, and in some sense protecting it, right, from our procedural processing. But of course we have the reverse problem. Stanovich has only got half the thing. There are many instances where we have to protect our procedural processing from interference from our propositional processing, right? So if I'm sparring with Leo, not a wise thing to do, by the way. He's a master, a virtuoso. He can kill several of you if he wishes to at any moment. Right? And I have sparred with Leo. It was one of the peak events of my life, because it was, wow. Okay? I cannot get into propositional processing. It's like when I said about, you typing. If you start doing all that propositional processing, this is actually a studied phenomenon in psychology. It's called overshadowing, right? If you get into that, it will actually degrade your procedural abilities dramatically. So what we need is another learning to learn cognitive style that will, help us pay attention and clean this up and help protect it from interference from propositional processing. And I want to argue that we know what that is, and we already have a lot of independent research on it, and that's mindfulness. Right? It's one of the areas I do work on, the science of mindfulness meditation. Because in mindfulness, what you're actually doing is you're trying to shut down a lot of this propositional processing. You're trying to focus your attention not on the world, but on your procedures for attending to the world, and you're trying to get, increased clarity about how those should operate. I can't go into great detail about what mindfulness is. Many of you have seen other talks that I've given on this. And that means we've got this really important dynamic going on here. We've got this rationality for our computational abilities, and this rationality for our interactional abilities, and we also need to properly coordinate them together. Now I'm going to make a suggestion to you. If rationality is intelligence fed back on itself, then perhaps wisdom is rationality fed back on itself. Namely, we could get a higher order kind of rationality that coordinates these rationalities together. And we do have something that coordinates procedural and propositional knowing together, perspectival knowing. Perspectival, okay? And what this can do, right, is this is a higher order. This is like a higher order. This is a meta-cognitive style that can actually monitor and modify these cognitive styles so they are operating in an optimal relationship to each other. So we can have a rationality, right, of our rationalities. Now, this is also a system that's dynamically self-organizing. And notice that if I'm doing this, the system is complexifying because I'm differentiating, I'm differentially improving each one of these, but I'm also integrating them together. I'm simultaneously differentiating and integrating my rationality. My rationality is self-complexifying in this way. It's getting emergent abilities. It's transcending itself. That would mean that wisdom is rationally self-transcending rationality that enhances relevance realization. Now that sounds sort of really, I hope, at least cool, right? Is it still on? Okay. Unlike these where we have some well-studied psychological machinery, right? This isn't so well out. Now, I think some important work is being done, and I think Michel, for example, tomorrow will talk about the role of narrative in this perspectival knowing and how important it is. I won't steal his thunder. I like Michel, right? But I want to tap into an idea that Leo and I have talked about this higher order meta style of rationality that affords rationally self-transcending rationality. And we use the Greek term for this, sophroson. Now, this is an incredibly hard word, like any important philosophical word from Greek, to translate. All of our translations of Greek philosophical terms become career avenues for philosophers. You can spend your entire career just arguing about what sophroson means. The usual translations of moderation and temperance are really misleading. They do not capture the dynamics of sophroson. And the way to bring this out is by contrasting it with another idea, enkratia. Enkratia means like self-restraint. So, I want the chocolate cake, but no, I will not have the chocolate cake now. I suffer, and there's torment and inner conflict, and I sweat, and right, and all that sort of stuff. Okay? Sophroson is considered a state beyond that because it's considered graceful and effortless. Okay? And one of the classic ways in which thinking about it, I'll actually quote a passage, at least it's famous, I hope you're familiar with it, but it's an instance of a phenomena that was extensive throughout the ancient world. So perhaps you don't, but in the book of Corinthians, Paul is giving his famous hymn to love. You know, people read it at weddings, which is completely ridiculous because it has absolutely nothing to do with romantic love. It's about agapic love, right? And Paul even announces this. Before he goes, nobody reads the first words. Before he goes into the hymn, he says, "And now I will show you a more excellent way of life," right? And he goes, you know, the familiar. If I have knowledge and prophecy, but I don't have love, I'm worthless, I'm empty. And this is a very famous passage. And people usually read about all the wonderful things that are said about love. Love is kind, it's not arrogant, it seeks the truth, it rejoices in goodness, all that sort of stuff. And I don't mean to trivialize this. I think it's a great passage in the Bible. What Paul interrupts, and he says, you know, when I was a child, I thought like a child. I spoke like a child. But when I became a man, I put childish things behind me. And people, that's important. He's trying to give you a really important clue as to what he's talking about. And then he gives you a second clue. He says, now it's like we're looking in we're only seeing things in a dark reflection. We don't see them as they actually are. And what does he mean about that? Well, I want you to compare Spencer and myself. Spencer's my younger son. My older son, Jason's here with me today. Yay, Jason, right? And so his younger brother, Spencer. So Spencer has a toy tower. You come into the house, and there's toys and a tower. And kids are organized, like he's 7. Kids are organized around 2 deities, candy and toys, right? Everything else is an obstacle or an affordance for candy and toys. This is one of my favorite stories about Spencer. I once asked him, what's more important, candy or toys? And he looked at me, now Daddy's asking a good question. Daddy usually asks stupid questions, but here's a good one. And he stopped, and he actually said to me, he was like 5, and I was like, he said, I want to think about this. A 5-year-old. It's like, oh, there's my son, right? And then he said, he came back to me and he said, toys, because sometimes you get filled with candy. Okay, so when Spencer comes in and it's not time for play, he's into Encratia. Oh, don't play with the Incredible Hulk. Don't play with the toys. Notice when I come in, I don't face that. I don't go, oh, there's the toys. Oh. Okay? The toys are not part of my salience landscape. They don't even come onto my radar. I just naturally or effortlessly or gracefully ignore them. It's not that I'm not aware of them. They just do not call me in the same way they used to. And Paul was trying to say, when we move to agapic love, we're no longer under the law. We're no longer, constrained by all these rules. Because if we have a certain salience landscape, if we relate to ourselves and others in a certain way, we will effortlessly do what is right. Now, and he indicates that that's going to keep getting better because we're only at the preliminary stages of it. At some point, that ability, that sophrosenic salience landscape will get even better. Now, this brings up a very pervasive metaphor for wisdom in the ancient world, and Pierre Hadot talked a lot about it. It was actually sort of an analogy. As the child is to the adult is to the sage. And that's what Paul's invoking, that widespread analogy. When I was a kid, I wasn't capable, I didn't have the competence, I couldn't see through a lot of temptations. But now I can. But, right, there's another stage, there's a rebirth, a transformation that is possible to you, in which you will move to yet a higher stage, in which things that were previously required Encratia will become sophrosenic for you. So now we ask, well, how do we get sophrosin? And I want to talk about a very important idea about this kind of development, child to adult. Very central figure, Vygotsky. Vygotsky talked about an important process of this. He talked about a process of internalization. Now, he used Hegelian language. He used the language of dialectic. But we can actually translate that, I think, in a way that's fair to him, into the language of complexification. So here's the idea. Imagine I'm trying to teach Spencer something, right? I'm trying to teach Spencer something, and Spencer and I, so we're looking at the problem. But Vygotsky's idea is, Spencer's not just paying attention to the problem, he's also trying to pay attention to how I pay attention to the problem, right? And you can show this in a lot of very, very interesting ways, because kids will stay focused on that in ways that might make them seem actually not intelligent. Just a classic experiment on this. So you have this gizmo, and you have a chimp in front of you, and you push all these levers and push all these buttons, and then at the bottom, right, like say a candy comes out. And the chimp watches you do this a couple times, and chimps are really smart. And then it can repeat what you do and get the candy. And you can do it with a 4-year-old. And oh, kids are as smart as chimps. Yeah, well, that's good so far. Then you replace that box with a translucent box. And it becomes quickly apparent that the only thing that releases the candy is the last action you perform, this thing. All the rest of it's nothing. The candy comes out. The chimp, when you give them the opportunity, doesn't do all this stuff anymore that you just did. It just does the last thing and gets the candy. You go, wow, smart chimp. Ooh, yay. Here's another candy, chimp. You go to the 4-year-old watches and clearly sees that only the last thing works, and the 4-year-old repeats everything you do. And you go, oh my God, 4-year-olds are stupider than chimps. But they're not. Short term, the chimp is winning. Long term, the kid is winning. Because the kid is investing in trying to imitate the adult, trying to take the adult's pattern of attention. So think about it this way. Here I am, here's my son. He's not only paying attention to the problem, he's paying attention to my perspective on the problem. Now, one of the things that's in my perspective on the problem is his perspective. Yes. Now, as he starts to take my perspective, he's differentiating his consciousness, but eventually he can internalize it. I don't need to be there. He can look at his own cognition through my perspective. He becomes aware of his own cognition. He makes possible learning to learn by looking at it through my perspective on him. And that means he can become aware of bias that he can't normally see through his perspective. He can take on interests and explore in ways he wouldn't be motivated to do from within his perspective. He can become much more rational. Now that process of internalizing the adult is exactly what Leo and I propose is going on. Wisdom traditions get us to internalize the sage. Paul said, "It's not I who live, but Christ who lives within me." The Stoics were about trying to internalize Socrates. The Epicureans practiced regularly. They put Epicurus' statements on their furniture, on their toiletries. They were trying to internalize Epicurus. In Buddhism, we take refuge in the Buddha. It doesn't mean we worship the Buddha or image the Buddha. In fact, for the first 5 centuries, there are no images of the Buddha. There are footsteps. We're supposed to follow his perspective. We're trying to internalize the Buddha and realize our Buddha nature. That's what it is to internalize the sage. And Leo and I argue that that's one of the primary psychological processes by which we complexify our perspectival knowing in that Vygotskian manner and acquire sophrosyne. Look, this is really, really important stuff. It's been mentioned. We're facing a crisis. We're facing crises of meaning, like we see in the Occupy movement. Things aren't right. We don't know. Our sense of how things are relevant, how they matter, what's important, how they fit together. We're losing our grasp on this. And this is interacting with our other crises. Our crisis of despair is interacting with our environmental crisis of degradation. It's interacting and exacerbating our economic crisis of debt and disparity. It feels like on every dimension of human experience, we're going into the dark. But science is affording us an opportunity we have to have the courage and commitment to take. We can light the lamp of wisdom in the encroaching darkness. Thank you very much. I don't know. I mean, here's some things I can say. So when you're talking about nature, you mean something like personality traits, constitutional traits? Yeah. So one of the things that probably is highly correlated with insight is the personality trait of openness, and people vary on that. But we used to think that the personality traits were like the big 5, like openness and neuroticism, things like that. We used to think that they were quite fixed. Or quite stable, I should say. They develop, but you know, if you were relatively if you didn't have a lot of openness as a 20-year-old, you're probably not going to have it as a 50-year-old. But there's been some recent and really important research. They did some work where they gave people psilocybin, and then they tracked the people who had mystical experiences off of the psilocybin, and what they found was a permanent increase in their openness. So certain kinds of experiences of sort of radical transcendence, and Dan Merker is going to talk about the mystical, right, can actually alter this and possibly afford, right, the kind of openness that's going to be more conducive to cultivating wisdom. You also need other personality traits. You probably need, although this is also associated with openness, you probably need a lot of need for cognition. Because need for cognition, this is where you provoke yourself to learn, that tends to be highly correlated with people doing a lot of learning to learn. Vanessa was saying if it has to do with relevance realization, then are we saying that a schizophrenic can't be wise? What Vanessa is implying, I think with good reason, is that schizophrenia is a relevance realization problem, a salience dysregulation disorder in which too much is found to be too relevant and too relevant to you. This is why you get, you know, complex patterns are being projected onto the world fantasies. I think that's true. I think going on the opposite end, if we're too restricted to featural processing, right, too localized in our processing, perhaps we're overwhelmed by anxiety, it's going to be very hard to cultivate wisdom. The difficulty with making the pronouncement just on schizophrenia is that the problem is, of course, schizophrenia makes it hard for you to be good at anything. So it's you know, but I think your conjecture is right. If you have if the relevance realization machinery is damaged in a way that you can't get much intervention in, then that's going to really restrict the possibility of you becoming wise. Yes, that'd be very difficult. Although with anxiety, we have more of an opportunity to intervene. I mean, look, one of the classic things about schizophrenia is they lack an important kind of self-insight. One of the telling conditions of schizophrenia is schizophrenics do not realize they're suffering from schizophrenia. Perhaps. I think the middle path is a middle in lots of dimensions. It's like this. I think it's trying to get this middle point between being, engaged with the world, but maybe, compulsively or impulsively, being reflective on the world, but being disconnected, getting a middle between those. I think the middle path picks up on a lot of things. I think one of them is exactly that, sort of putting things together and avoiding a lot of extremes. And I think the middle path is also a dynamical thing. I mean, this complexifying process, like I said, Vygotsky used like thesis and antithesis and synthesis, but we can use the language of differentiation and integration and higher order complexification, I think, fairly. And I think that's why for example, when we try and talk about wisdom, we get into these really weird linguistic binds, trying to capture it. And the middle path is about not getting too, I think, another thing it is about not getting too locked into trying to, statically and completely resolve into our propositions wisdom. So there's lots of aspects, therefore, I think, to the middle path. I can't answer that easily, and a better person to ask would probably be Jordan Peterson. What seems to be predictive of insight and these kinds of things isn't any one of those poles, but what seems to be very predictive is your overall capacity for cognitive flexibility. Your overall capacity to basically move around, right, the range and specifications of your cognition to readjust. So that probably makes sense given that the flexibility in self-organizing criticality is most predictive of people's intelligence. I think so, but I wasn't going to speak about enlightenment because that struck me as pretentious. Yeah, I think so, yes. Okay. I think trying to restrict the discussion of wisdom, and that was part of the preliminary, to any one of these levels of analysis is a mistake. So trying to restrict it also just to the social level is a mistake. I mean, because of course there's lots of societies of organisms that do not embody wisdom. I mean, that's clear. Now, I agree with the fact that wisdom, or perhaps to use your example, Buddhism has often been very badly misappropriated by the West as a kind of narcissistic romanticism, and that this should definitely be challenged. Some of you know that in other courses and talks I give, I specifically argue against and do challenge that thesis. So I sort of only partially agree with you. I mean, it's talking about societies as wise, I don't think should be rendered as somehow independent about talking about the cognitive capacities of individuals, because then you have this weird ontology floating above individuals.